Hey, welcome back to another RCWorks video. Today I wanted to talk to you about upthrust and downthrust, and more specifically kind of how that can impact your system as well as where it applies. So generally when you're talking about upthrust and downthrust, you're usually talking about multi-stage pumps. So a good example would be a submersible well pump. So let's first talk about what upthrust and downthrust is, and then I will give you some examples and kind of show you the inside of some submersible well pumps so you can get an idea of how that can affect your system in the long run. So without further ado. Alright, so what we've got here today is just a generic pump curve, completely made up. Now if we were to be looking at a submersible well pump, we would probably call this a 12-gallon a minute pump, because basically our middle point is at 12 gallons per minute, and that's our most efficient operating range. So if you're not familiar with the pump curve, we do have a video on how to read a pump curve in our channel here, and we'll try to link that in the description below. But basically on the left hand side you've got the head feet, which is just incremental, that's your feet, so 20, 40, 60, 80 feet. And then down here you've got your flow in gallons per minute. So one could say at 12 gallons per minute you've got roughly 150 feet of head. So anyways, on to downthrust and upthrust. So what you might have noticed if you've looked at pump curves before, specifically submersible well pump curves, oftentimes there's an area that's either shaded in blue if you're looking at Franklin Electric pump curves, or in the case of A.Y. McDonald pump curves, it's a green shaded area. And basically this green area, or where I've put the dashes, this area in the middle is what's known as your recommended operating range. So when you look at a pump curve, especially for a well pump, a pump that has multiple stages, you're wanting to operate that pump basically in that recommended operating range. Otherwise you risk additional wear and tear on the pump, which is going to ultimately cut into the life of the pump system. So you couldn't really expect to run way out here on this side or way out here on this side on a regular basis and get long life out of your pump, which is why it's important to have a pump that's properly sized. And of course we can help size a pump for you if you need that. But let's talk a little bit about downthrust and upthrust. So basically what happens is the stages in a submersible well pump are designed to essentially float in between the different diffuser rings. So you've got a stage, a diffuser, a stage, a diffuser, or an impeller, a diffuser, an impeller, diffuser, and each one of those, an impeller and a diffuser combined, is one stage. So we've got an example of that we'll show you in just a second, but first we'll kind of describe what this is. So think of it as, so the blue here in these little sections, so the blue, that's the impeller, and then this is your diffuser below it, and this is the diffuser above it. So during a downthrust situation, when you have a high amount of pressure above the pump but not a lot of pressure below it, you're basically pushing those impellers down, and the reason that the impellers move up and down inside of the pump is for better solids handling. So oftentimes, like if you were looking at Franklin Electric or some A.Y. McDonald product, you would find that they have really good sand handling capabilities. So if you've got the occasional bit of sediment in your well and things like that, then these pumps are going to handle that sand really well, because that impeller can move up and down. So when solids or anything come in contact with it, they're kind of just going to push the impeller out of the way and minimize the damage to the impeller. The trade-off to that, you might think, well, how about I just use stainless steel impellers that are going to be fixed in place, and oftentimes, like with pumps like Grundfos, you don't have the same type of setup where the impellers float or move up and down. They're more fixed, but that really limits your solids handling capability, which more in terms of volume of sand as opposed to size of the solids. So anyways, a good sand handling pump is going to have like glass-filled plastic glass-filled reinforced impellers, and it's going to have a little bit of play in the up and down, and that's why they have this recommended operating range. So you can see here in a downthrust position, when we're operating on the left-hand side of the pump curve, it pushes the impellers down because the amount of pressure, again, head equals pressure, the amount of pressure pushing down on the impellers is not what they're designed for, so it causes them to sink to the bottom and they rub against this diffuser, and that's going to cause a lot of wear on that impeller because it's just plastic reinforced with glass. So if you're operating within that recommended operating range, that impeller is designed to float between the diffusers so that you don't encounter that wear. And of course, in an upthrust position, when you're moving a lot of water but you don't have a lot of pressure, the water coming through is going to push those impellers up. Just like on this one, the pressure is pushing the impellers down because there's not a lot of water. So it's kind of a balance of the amount of water that's being sucked through the pump and pushed through the pump to push the impellers up, and then the amount of pressure bearing back down on the impellers that keeps it balanced right here in the middle. And that's why it's so important that you operate within that recommended operating range. So just to give you an example, I just wanted to make this video nice and brief to give a general overview of down thrust and up thrust and how that can affect your pump. I do have a pump or the insides of a submersible well pump I was going to show you and just kind of give you an example there. And just to give you an example, so upthrust would be very likely encountered if you were running a pump wide open with very little head pressure on it. So like if you basically took a well pump that's supposed to go down in a well and put it in a bucket of water and flipped it on, you'd be in an upthrust position because you have no head pressure pushing down on the pump. And then down thrust, you're likely to be having a partially closed valve or running a very low volume of water on a regular basis, which is why it's important to have a pressure tank. And having that pressure tank basically means that when you size your system, you're going to always be operating in the middle as it's filling that tank up. So when the pump kicks on, it's probably going to be somewhere out here, and as the pressure increases in the system, it's going to be up here, the tank's full, pump shuts off, cycle starts all over again. So that's an ideal situation. So let's go jump into what I've got set up over here and we can take a look at it. Alright, so here we are. You can see I've got a submersible well pump, and this is actually something that we use in our showroom to demonstrate this to folks. So you've got these impellers in here, and this is a cutout obviously. So these impellers are going to rotate around. That's this white bit that you see here, and ideally you want those to be centered and not rubbing on the diffuser below or the diffuser above. So hopefully you can see that alright. And so what I've actually done here is I've got a pump that I took apart, and so these actually, like I said, they just sit in there. So here's the top diffuser, here's the impeller, and they simply are just set in there. So the idea is you want to keep those balanced inside of that pump, because if you're sitting in a situation with down thrust, then this is going to be pushed down, and when it rotates, it's going to be grinding really hard on this diffuser below it. Just like if you were in an upthrust position, it would be grinding really hard in here. Now, it's not a whole lot of friction that you experience, but when these things are spinning at 3,450 RPMs, you can imagine the kind of damage that you could cause. I could probably sit here and do this all day, and that wouldn't equal 3,450 RPMs over the entire day. So when it comes to this style of pump, you're basically sacrificing overall performance and longevity for the ability to operate the entire range of the curve. And I think that there are some manufacturers out there, like with stainless steel pumps, where the impellers are fixed in place, and also with like turbine pumps, where you can get away with a little bit more upthrust and downthrust and have a slightly wider range of operation. But in a residential setting, it's very easy to size the pump to where it's going to always operate efficiently, and it's going to always operate in its recommended operating range, because you don't generally need that broad range of operation. So I think that this pump design is absolutely ingenious, and I'm not saying that you need to go with the stainless steel pump, because I find that those pumps in particular aren't able to handle sand as well, and they're more likely to get bound up. And if it gets bound up, you're looking at a burnt motor. If you look at this pump and it passes the sand through it and takes a hint of wear along the way, that's much better in the long run when you're talking about the replacement costs of setting a new well. So hopefully with this video you were able to kind of get a little bit of an understanding of what upthrust and downthrust is and how that impacts your water well system. I highly recommend that rather than just go out and buy a well pump, You know, if you had a pump that failed in under 5 years, give us a call. We're happy to size up your system and give you a recommendation on the most ideal pump for your situation. So thanks for joining us today, and we'll catch you next time. Oh, I've almost forgot. Don't forget, new videos Tuesdays and Fridays, and subscribe if you haven't. It helps our channel a lot. And don't forget that thumbs up. We'll see you later.